Hey there, this is Horner, and this is equilibrium exercise number 5. We have Yvette who has a 24 Newton, so here's our 24 Newton bird feeder. She's hanging it between two trees, and the line that she hangs it on is 4 meters long. When she does that, because it's got some weight to it, it actually pulls it down, and we're looking for how much that line sags. We know that the force due to gravity for the bird feeder is 24 newtons, and we know that the tension in each one of the lines is 480 newtons. So this is one rope, and then when you pull it down, now it becomes a left side and a right side to the rope. So let's go ahead and draw a free body diagram for this one. Let's put our dot, and then we'll have moving straight down is the force due to gravity. We have going up to the right is a force of tension, and then up to the left is another force of tension, and those, believe it or not, are the same number. We see that 480 and 480, so we can treat them that way. Let's go ahead and make a triangle out of the left one in one color, and then we're going to make a triangle out of the right one in a slightly different color. And notice that we do have the same line going straight up and down for both. It actually should be the same line, just doesn't look like it here. We are now going to put in our angle on this side, and then we'll go ahead and it is the same angle on this side. And we need to talk about what is this top part of the triangle and what is the inside of the triangle. Well, if the force of tension is this long line here, we can say the top is Ft times the cosine of the angle because this is the adjacent side. And then the side that is on the opposite side is Ft sine of the angle. We're going to do the same thing over here. This is F times T times the cosine of the angle. And then we also have F times T times the sine of the angle. So let's go ahead and do some math. We're going to start with the sum of the forces in the x direction, and that's equal to 0 because this thing is not accelerating. We have Ft times the cosine of the angle minus Ft times the cosine of the angle is equal to 0. And all those just cross off, so don't worry about the x direction at all. Let's look at the sum of the forces in the y direction. Those are also equal to 0. It's a static environment. It's not moving, and the most important thing is it's not accelerating. So the sum of the forces in the y. We have two things that are Ft sine of the angle both going up, and they're both the same because the tensions are the same. We're going to subtract from that Fg, and that's equal to 0. Now, we're looking for the angle. So to find the angle, first thing we'll do is we're going to say 2 times Ft times the sine of the angle is equal to Fg. Now we need to divide both sides by 2 Ft. So we're going to end up with sine of the angle is equal to F times G all over 2 times the force due to tension. And that leaves our angle equal to Fg. Oops, their angle is equal to the inverse sine of Fg over 2 times the force of tension. So let's plug our numbers in. This is the inverse sine of 24 divided by 2 times 480. If you do that math, you'll find out that that angle is actually pretty small. It's only about 1.4 degrees. So 1.4 degrees. Now, that's either one of the angles. So let's just use this triangle left. It's the same as this triangle right here. And we'll redraw the triangle. And we know that this is a really small angle of 1.4 degrees. We know that the whole rope all the way across is 4 meters, so we only want 2 meters. And we're going to look for what is the length of the rope that is now bent down. So how far does it sag? To do that, we just use really just some basic geometry. We know that we've got the adjacent side. We're looking for the opposite side. And to do that, we're going to say that the tangent of 1.4 is equal to x, that's what we're looking for, over 2. And so our x will be equal to 2 times tangent of 1.4, and we'll be left with 0.05 meters, and that is the sag in the line. So we've got to do all this to find the angle. Once we know the angle, then we just use some simple trigonometry to find out what the sag is. And that is the end of exercise number 5 in equilibrium.